So usually everyone is waiting for an opportunity to knock our doors, but always knocking is a not a good idea. Sometimes knocking may also makes noise. And today topic is knocking octane number and cetane numbers regarding fuels. And this is the eighth topic in fuels. You can watch all my videos corresponding different topics in my YouTube channel, and corresponding links was provided in the description. Before going to knocking process, we need to know the how internal combustion will works. So it is also called four stroke engines because of there is a four strokes continuously involved in the internal combustion engine. First one is intake. Engine obtain the petrol from the tank. So first in first stroke, so petrol is obtained from the so this is the petrol tank. So this petrol is taken into the engine. This is called intake. So this is going down, the shaft is going down. Okay, now shaft is coming upside, so that means it is compressing the intaked petrol. So that means when you apply the more pressure, it easily involved in combustion. That's why we need to compress the what we uptake the petrol into the engine. So now the petrol is at high pressure. When you give the spark by using the plug, it involved easily in combustion process. When it is involved in combustion process, it produces large amount of heat energy. Because of heat energy, it pushed very fastly into downside. So because along with the heat energy, it is also produced the combustible gases. That combustible gases will be removed by the exhaust stroke. So these are the four strokes continuously will happen in the internal combustion engine. So if you observe the compression stroke, if you able to compress more highly, you can produce the more heat energy. Both are directly proportional. Okay, compression and combustion. If you compress very high, you can produce very high combustion rate. That means you produce very high amount of heat energy. If you get more heat energy, you will get more capacity, or it will run very fastly or higher distance. Okay, so that is the process. Compression is very important in the internal combustion engine. So you can see here, so four strokes in a one figure. So first one is, see here, first one is intake, compression, combustion, and exhaust. Okay, like that will happen. So compression rate depends on the boiling point of fractions present in the petrol, sorry. So petrol is a C5 to C9 composite composite one, and its boiling point is 40 to 120 degrees centigrade only. Okay, for example, petrol may contains 40 degree centigrade boiling point compounds, or 80 degree centigrade boiling point compounds, or 120 degree centigrade boiling points. If you have a 120 degree centigrade boiling points throughout your petrol, what will happen? Its boiling point is high. That's why you are unable to compress very easily. If you are unable to compress easily, you will not produce more heat energy. Okay, so if your petrol having only 40 degree centigrade boiling point compounds, this boiling point is very low. You can compress as you like. You can compress maximally. You can produce maximum energy. So compression depending on the boiling points. So heat energy depending on the compression rate. So compression depending on the boiling points. So if you observe the boiling points of different hydrocarbons, straight chains hydrocarbons having lower boiling point compared to branched, compared to alkenes, compared to cycloalkanes, and aromatics having a high boiling points. So if your fuel contains only aromatics, what will happen? Only aromatics means aromatics having a high boiling point. You are not able to compress as freely as you can. So that's why compression rate decreases, it produced heat also decreases. Okay, so you can see here straight chain hydrocarbons and alkenes. So next one is, so this is actually 1313 butahexene. So next one is a hexane, cyclohexane, and it is a benzene. All are having only C6 carbon compounds only, but their boiling points are different. So compared to straight chain, alkenes having high boiling points compared to alkenes, cycloalkanes having high boiling points compared to that one, aromatic compounds having high boiling points. If compression rate is high, it produces high amount of heat energy. So, but there is another problem is also there. That is, if you compress more than certain limit, if you compress more than certain limit, it produces a problem. That problem is called knocking. So remember this one thing, compression is good. Compression is good to produce heat energy, but the compression rate is more than certain limit. It's create a problem. That problem is called knocking. Knocking is metallic sound. Metallic sound produced by the exposed combustion gases when they compressed higher than certain limit. There is a 3 point. First one is it is a metallic sound. Who is producing? Exposed combustion fuel gas are producing. When they are producing, when they are compressed more than certain limits. So you have a tank here. So by using piston up to here, by using piston you can compress the fuel. Okay. So this is the capacity. So if you compress up to here, that means you are compressed you are creating very much high pressure. So now before combustion fuel gases involved in free combustion, and they don't have space to go anywhere, and they create sound on the metal means on engine. So they create sound, and that means when the fuel is involved in combustion, this piston will come down. But before combustion, these combustible gases, these fuel gases involved in free combustion, and these gases make a sound on metal that is called knocking. Knocking is a metallic sound produced by the exposed combustion fuel gases when they are compressed more than certain limit. So why? Because gasoline is a C5 to C9 carbons and have a low boiling point 40 to 120. So if it is have, due to over compression, the fuel IC engine ignited spontaneously, producing explosive violence known as knocking. So before combustion, they involved in combustion. Before start the combustion process, the fuels itself involved in the combustion. Okay, and they produces the explosive gases. That gases make a sound on the steel vessel, that is a engine. Okay, so see here. So now it is only compressing up to here only, right? Up to here only it is compressing. Up to here only it is compressing. If you compress up to there, now more pressure will generated. So because of more pressure, here combustion is starting. If you observe here ignition is starting. Before ignition, they involved in combustion, they produce a sound. So if you observe the boiling points, boiling point is very high for the aromatics. Okay, now my question is, in the straight chains aromatics, who can more compressible? Straight chains or aromatics? Straight chains are low boiling points. That's why they can compress very highly. That's why these can produce very high sound. Okay, very high noise. So if you see the knocking order, straight chains having high knocking property than the aromatics. Aromatics are least, but boiling points is opposites. Aromatics has high boiling points, straight chains are low boiling points. So knocking is just opposite to boiling point ranges. Okay, so next one is, so diesel knocking. So if, up to now what we learn, that is the petrol knocking, that is internal combustion engine, how petrol involved in knocking process. Next one is diesel knocking. So diesel knocking also same just like petrol knocking, but in diesel engine what happening, first of all we will not intake diesel into the fuel. We will not intake diesel into the fuel engine. Okay, we will intake air. First we will compress the air, then we will spray the diesel over high compressed air molecule, then it is easily involved in burning process, combustion process. So here air molecule is compressed. If the air molecule is highly compressed, now that air molecule makes sound, that sound is called diesel knocking. In petrol knocking, explosive combustible gases are making sound. In diesel knocking, air molecules are making sound. This is the only difference, remaining are same. Okay. And what is anti-knocking agents? Anti-knocking agent means the chemical additive which is used to decrease the knocking property of petrol or diesel. So what we are using, the different chemicals we are using along with the petrol or gasoline to decrease, to reduce the sound noise, that is knocking, is called anti-knocking agent. Tetraethyl lead, methyl tertiary butyl ether, these are the commonly used things, but TEL is not using nowadays because of environmental issues. So best option is methyl tertiary butyl ether. So go for the octane number. What is octane number? Octane number is the measurement of anti-knocking property of the petrol. Remember here, octane number is not measuring of the knocking property. It is a measurement of anti-knocking property. That means if a petrol having high octane number, if a petrol having high octane number, it have a high anti-knocking property. High anti-knocking property means it has a low knocking property. Low knocking property means it produces very less sound. Okay, so just observe this trend. So high octane number mean high anti-knocking property. High anti-knocking property mean low knocking property. Low knocking property means less sound. So reversely, if it has a low octane number means low anti-knocking property. Low anti-knocking property means high knocking property and it produces much sound. Okay. So for example, if you take N-heptane, so here 1, 2, 3, 4, 5, 6, 7 carbon straight chain. We already know straight chains have a very less boiling points. Less boiling points mean we can compress more than certain limit. If you compress more than, they produces much sound. That means knocking is very high. Knocking is very high means anti-knocking is very low. Anti-knocking is very low means octane number is very low and it is taken as 0. So for N-heptane, octane number is 0. And branched hydrocarbon chains, for example, if you take 2,2,4 trimethyl pentane, it is also called isooctane. Isooctane, octane number is equal 100. That means octane number is 100 means anti-knocking property is very high. Anti-knocking property is very high means knocking property is very low. It doesn't produces or it produces very less sound during the running of motor vehicle. Okay, so if your fuel only having isooctane, it will not produces any sound. If your fuel, if your petrol only having N-heptane, it produces sound. If you start here 1 kilometer, people also came to know you are coming, like that sound will come. Okay, so that is the octane number. Okay, next one is cetane number. So cetane number is corresponding to diesel fuel. Okay, octane number is about petrol and cetane number is about diesel. So diesel is not just like petrol. Petrol boiling point is very low. Its maximum boiling point is 120. But diesel have up to 250 degrees centigrade. Diesel have a higher hydrocarbon chains, longer hydrocarbon chains than the petrol. So it has a high boiling points. They are not easily involved in ignition in a diesel engine. It is very difficult to start the car. So when you on the car, so it takes some time. That means when you start the car and when it is started, between some gap is there. That gap is called ignition delay. That means when you trying to start car, it takes some minutes, some seconds. That seconds is called ignition delay. So cetane number is measurement of ease of ignition of diesel fuel. How easily it is involved in ignition, that can be represented by the cetane number. If cetane number is high, it easily ignited. That means there is no delay. So when you start, within microsecond, it will start. Okay, that is called high cetane number. If cetane number is low, means it has a ignition delay. It not easily involved in ignition. Okay, So that is the cetane number. For example, if you take a 2-methyl naphthalene, so 2-methyl naphthalene means this one. So 2-methyl naphthalene cetane number is 0. That means, so cetane number 0 means there is a ignition delay. So it will take much time to start your car or diesel engine. Okay. So but hexadecane. So hexadecane means 16 carbon chain. 16 carbon chain. This is also called cetane. Cetane number is equal to 100. Okay. So if you feel, if your diesel having only cetane, it easily involved in ignition. There is no ignition delay. Okay, this is the cetane number. So just look at the different parameters here. So what is boiling point, what is knocking, what is anti-knocking, what is octane number, what is cetane number. These all are interlinked each other. See, observe here. So first we look at the boiling points. Look at the boiling points. So boiling points, straight chains are low boiling points, aromatics are high boiling points. Okay. So knocking is just reverse. If boiling point is low, we can compress very much. That means it produces very much sound. That's why knocking property is very high per straight chain. If knocking property is very high, anti-knocking property means it reverse. Anti-knocking property and octane number both are same, and it is opposite to the knocking property. Okay, remember it. So this is same. If you observe here, boiling points and knocking anti-knocking property are same order. And next one is cetane number. Cetane number and knocking properties are same order. So you can understand these things by a concept. That mean anti-knocking property mean low knocking property. When knocking will arises, if a fuel having low boiling point, it can compress more than certain limit, then only it produces sound. So what is cetane number? Cetane number is measurement of ease of ignition. That means the fuel easily involved in ignition. Which one easily involved in ignition? High boiling point or low boiling point? Low boiling point compounds are involved in ignition. That's why straight chain paraffins involved in easily ignition. That's why the order of boiling points and the order of boiling points and knocking property, order of cetane numbers and knocking property both are same. Straight chains have higher knocking, straight chains have higher cetane number. So boiling points, aromatics are high boiling points, aromatics have high anti-knocking property. So remember it. So thank you for watching this video.